So if we continue on with our discussion of using property tables, we've looked at a couple of examples where we line up perfectly with values that are already on the tables. And I know maybe some of you that are a little more grizzled or a little more cautious, like Steve. What do we do when we don't line up perfectly on the table? Because we know that would be much more realistic to not line up on the tables. Okay, so that's it's actually much more common that we don't line up perfectly. So what do we do when we're not lined up perfectly? Well, once there's a couple of main situations where that's going to occur. One of those is if I have a saturated mixture, right? If I have a saturated mixture. So if I have a property, whether it's V, U, H, or S, and that property is between the values for a saturated vapor and a saturated liquid, that means we have a saturated mixture. It means saturated mixture. And so to find the saturated, and we can see that we look at this on where I put T, P or T on the y-axis, and I put V, U, H, or S down here on the x-axis. Then I get, this is my dome region. And remember, we said that saturated liquid is the F value, and saturated vapor is over here on the G value. That's assuming at the given pressure or temperature. I get a V, U, H, or S value that's between the values for saturated liquid and saturated vapor. I am in here somewhere. So that means some of it is vaporized, some of it is still in the liquid form. We need to figure out where we are. How far in between those two values are we? And that will allow us then to figure out the other properties. We figure that out with what we call the quality, right? The quality is the amount, the quality is the portion in the vapor phase. Portion in the vapor phase, right? So that quality value, that X value, is going to be between 0 and 1. It's basically the percent or the portion that's in the vapor phase. So if I've got a quality of 0.9, that means it's 90% in the vapor phase. If I've got a quality of 0, that means it's saturated liquid. If I've got a quality of 1, that means it's 100% in the vapor phase. So I have a saturated vapor. Right? So you can calculate it based on specific volume. You can also calculate the same quality based off of the other properties so that I could have U minus U sub F divided by UG minus U sub F. Notice the same ratio I would write for, the same ratio I would write for specific volume. I can write the same ratio for internal energy. And remember that in your text, our text is a little bit nice to us in some aspects. They give us this UFG value. The UFG value is, I'm sorry, I keep rolling my mouse wheel. The UFG value is the same as the difference between UG and UF. Those are the same values. So you could just pull that off the table if you like. So once I know the quality, whether I find it using specific volume or I find it using a U value, I can use that same quality then to find other properties as needed. So H minus HF over HFG, that's going to give us the same X, same quality ratio as I would use for any of the other properties. Same thing in a second law problem if I need to know the entropy. S minus SF divided by SFG. Once I've found X for one of the four properties, I can use that same X to find any of the other three properties. It's the same quality. I've got the same amount in the vapor phase and the same amount in the liquid phase, given a specific set of properties to get me there. Okay, so let's look at an example of that. So let's say that I've got water. So let's write this out or what we know here. Another example, given that I've got water, I've got a temperature of 170 degrees Fahrenheit, and I've got a specific volume of 50 cubic feet per pound mass. Okay, so that's what's given to me. And I want to find the pressure and I want to find the internal energy. Okay, I'm just going to find the lowercase u. We could, because we weren't given a mass, so we can't tell you the total u. We're just going to find the specific internal energy. Okay. All right, so I don't have, so I'm just going to actually work this out on the document camera because I don't have any real usable information here in the PowerPoint slides. I just have a space that I can write some stuff on PowerPoint slides. So let's just look in the document camera. Okay, so first thing we need to do is figure out the phase. Well, what do I have? I have temperature and volume. So when I've got temperature and volume, my diagram is going to look like this. I've got T, V, I just arbitrarily draw a curve. So at 170 degrees Fahrenheit, I need to figure out where I'm at on this curve. So given that, I can find my saturated liquid and my saturated vapor values for specific volume. So let's do that. So at this point, you want to have your book and be following along with me. I shouldn't necessarily have to put it under the document camera with you. I don't mind doing that, but just understand you really should be looking at yours. Yeah, mine's going to be all kind of crooked because I don't have a real good document camera. It's just kind of a portable one. So I'm going to have to kind of angle my book to get it under this in here. So table A4, that's, and I'm not going to try to focus because I leave the focus on that. So water, 170 degrees Fahrenheit, that's all the way down here, right? So water, 170 degrees Fahrenheit. This is my value for saturated liquid, and this is my value for saturated vapor. So I'm going to write those on my diagram here, right? So saturated liquid is the specific volume is going to be down here at 0.01645. And saturated vapor is going to be 61.982. And where are we? And again, both of these are, or all of these are cubic feet per pound mass. Okay. What are we looking for? What are we trying to do? We're trying to find pressure and internal energy, which means I need to know which table, which row I'm using. So I need to figure out the phase. Okay, what do I know? I know temperature and volume. Well, I know I've got a volume of 50, and I've just figured out at 170 that these are the limits for saturated liquid and saturated vapor, the dome limits. I'm up here at 50, which puts me right here in the dome region. I'm in between saturated liquid and saturated vapor. So I have a mixture. I have a saturated mix. Saturated mix. So if I have saturated anything, I'm going to have a quality value. The quality only makes sense. The X value only makes sense if I have saturated, if I'm from here to there and anywhere in between. Otherwise, the quality value is garbage. It doesn't mean anything. Don't bother calculating it. And we said the formula looks like this. My given specific volume, which I know, minus the specific volume for saturated liquid, divided by the specific volume for saturated vapor, minus the specific volume of saturated liquid, which we can write this out. Right, that's 50 minus 0.01645. Both of those are cubic feet per pound mass. I'll divide that by then the value for saturated vapor, 61.982, minus the value for saturated liquid, 0.01645. Both those cubic feet per pound mass. So I'm just going to factor it out so I don't have to write it each time. These cancel out. These are non-zero, and I've got the same thing on top and bottom of my ratio. So those go away. I'm just left with a unitless number, which is what I want for quality. All right, I could pause it here, but I'm just going to go ahead and calculate these out. I don't want you seeing it. So, okay. So I've got 50 minus 0.01645 equals, then I'm going to divide that by the quantity, 61.982 minus 0.01645. So I'm doing it on my calculator in the hopes that you do it in your calculator along with me because you're going to need to be able to use your calculator for an exam. And that takes practice. Using a calculator is just like any other skill, it takes practice. So notice I get a number there. I should get a number between 0 and 1. If I don't, you've made a mistake. 0.807, we'll say. 0.8066. You can write 0.8066. That would actually probably be better. Let's write 0.8066. Okay, so that's our quality. That we have a little over 80% in the vapor phase. Now, are we done? Well, I don't know. What are we looking for? No, we're looking for pressure and internal energy. Okay, so the fact that I've got saturated something tells me that the temperature and the pressure, the saturated temperature and saturated pressure are linked. So at 170 degrees Fahrenheit, as long as I'm saturated anything, my pressure is going to be basically 6 psi, 5.9999 psi. So because I've got saturated, my pressure then is going to equal my saturated pressure, which we can look up on the table to be 5.9999 pounds per square inch, pounds force per square inch absolute, psia. So that's my pressure. That's one answer. Now, the other answer I'm looking for is the internal energy. I need to find the internal energy. How do I find that? Well, I figured out how much of this is in the vapor phase. I figured out the quality. I can use that same quality then on the other properties, U, H, and S, meaning U minus UF divided by UFG will also be equal to 80.66. Now, I don't know U, that's what I'm after, but I can find these two properties here, right? So I've got and so I'm going to solve this out, right? So now U is going to equal X UFG plus UF, right? So U then is going to equal my X value of 0.8066 times my UFG value, which I'm going to go ahead and put it into the camera, but kind of at an angle. You should be looking it up in your tables, right? UFG and 170. So UF is going to be on 138. UFG is 927, 927.08, 927.08, 927.08. That's going to be kilojoules. No, that's going to be BTUs per pound mass. These are English units. So it's BTUs per pound mass. And then the U sub F value, I believe, is 138 even 0.00 BTUs per pound mass. So I've got the same units here. This is unitless, same units here and here. So I can add those together. Let me bring my calculator back up. We're almost out of time for this video, so that's actually going to work out just fine. So there's my quality. There's my quality. I'm going to multiply that by the UFG value here of 927.08. Again, you should be doing this along with me for practice. So that sum is, or that product is 748 basically. I'm going to add to it the 138 for the saturated liquid value. And that's going to give me a total there of my U is 8, we'll say 886. 3 significant figures is enough. 4 is only okay if I've got a very specific reason. 5 or 6 is going to be wrong. Almost always, unless you've real expensive equipment. 886 will be just fine. 885.8 would be correct. 885.814 would be wrong. I would take points off of that because you don't know these numbers out here. Okay. All right. That's my other answer. Hopefully this helps. That's one situation where we don't line up perfectly with values on a table. That's when I have a saturated mixture. I'm basically kind of at the end of this video, so I'm just going to talk for the last few seconds here. In the next video, we'll talk about what happens when I'm between rows. We're going to use a tool we call interpolation. And there's my timer.